Hello viewers, I am Sumin David. I am going to discuss about the geological consideration for the site selection of a dam. As we know, dam is a structure which prevents the flow of the water and accumulate it in a reservoir. Dam is a most costly civil engineering structure which construct to fulfill the demand of drinking in domestic water supply, for the flood control, irrigation, industrial water supply, hydroelectric energy production, and retention and control of the sediment. Now, classification of the dam. Before going to the classification of the dam, I would like to share that the Maharashtra is a state which is having the highest number of the dam. The largest dam of the India, which is almost embankment or the embankment dam, that is on the Bhagirathi river at Uttarakhand. Name of the dam is the Tehri Dam. According to the statistical design of a dam, dams may be of four types, that is, one is gravity dam, arch dam, buttress dam, and composite dam, which we also know. Composite dams are also known as the embankment dam or the earthen dam. Gravity dams use their triangular shapes and the sheer weight of these rocks and concrete structure to hold back the water in the reservoir. The most famous example of the gravity dam is the Bhagna Nangal Dam. When properly constructed, the gravity dam is considered as the safest type of the dam. But the necessary condition for the gravity dam is that the foundation rock should be very strong enough, because in this dam, the weight caused by the impounded water plus the self-weight of the dam will directly transmit it to the foundation rocks. Arch dam, it is constructed at the area where the rocks inside the valley are not suitable or they are not at the shallow depth, but the side rocks are properly visible. We can work on that. These rocks are known as the embankment rocks. When the strength of the embankment dam is enough, then we can construct the gravity dam. In a gravity dam, here we can say this is the upstream side, reservoir side, and this is the downstream side. The arch action or the convex side of the dam should always be towards the upstream direction. Example is Idukki Dam in the Kerala. Buttress dam, these are the concrete dam in which there is a deck which is sloping in the upstream direction. This deck which is sloping in the upstream direction, this deck takes the entire load of the water and which is supported by the buttress, or the buttress are the cross walling in the deck. With the help of these buttress, the entire load of the dam can be distributed in the wide area. So thus, when their rocks are slightly weaker, we can construct the buttress dam. Embankment dam or the earthen dam, this type of dams are constructed in such a place where the underlying material is too weak to support the masonry dam or where the competent rocks occur at the greater depth. They are built with the material which is locally available. In this dam, we provide a huge base which can extend the entire weight of the dam in a large area. The second figure shows this is the picture of the Tehri Dam, which is in the Uttarakhand, the Bhagirathi river. This is again a type of embankment dam, because in the entire Himalayan regions rocks are very weak. They are intersected by the lots of folds, faults and joints. So this type of rock cannot bear the huge weight of the masonry structure. So earthen dam may constructed in such type of the area. This is the cross section of the gravity dam, arch dam, buttress dam and the embankment dam. Again a picture of the four type of dam: arch dam, buttress dam, gravity dam and embankment dam. Now for all the practical purposes I am considering here I am taking the example of the gravity dam. When we discuss about the part of the dam, the most important part of the gravity dam is the spillway. This is a opening which is for the removal of the excess water which is at the maximum water level. The second important part of the dam is toe and heels. Toe is the part of the dam which comes in the direct contact with the rocks in the downstream side, while the heel is the part of the dam which comes in the contact of the direct rock towards the upstream side. The highest point in a dam is termed as the crest. Sometimes we may left some spaces at the base of the dam which are known as the inspection gallery, which is generally used for the inspection purposes, whether if there are some cracks at the base of the dam. So we can stand here. This is like a small room for the inspection purposes. Sometime when the height of the dam is very high, like we have the example of the Tehri Dam, its height is more than 265 meters. When height of dam is more than 200 meters, sometime we may provide a spillway apron, that is the RCC structure at the base of the dam, which is provided to prevent the wear and tear of the foundation rock, which may get damaged or which may tear by the continuous action of the downflow of the water in the dam. There may be another opening which is at the base of the dam, which is known as the sluice. This opening is for the removal of the clay which is provided at the base of the dam, that is sluice. As dam is the most expensive civil engineering structure, so before constructing the dam, it is very important to go for the preliminary investigation at the dam and the reservoir side, because the failure of the dam not only cause to rise many folds, but it may be also a problem for the people who are staying in the downstream direction. The detailed investigation at the dam sites are the topographic survey. This covers the preparation of the cross section with the help of Survey of India sheets and sheets provided by the Geological Survey of India, the geological map. Underground exploration is the very important task, because here the weight of the dam will directly transmit to the foundation rock, so it becomes very necessary to understand about the foundation rock. This type of information we can significantly get from the boreholes, and we can calculate the RQD and the joint frequency index. Hydrological survey are also important to know what is the groundwater condition at the base. Slope stability analysis is also becomes important when we are considering the safety of the dam. Now we will discuss about the forces acting on a dam. The most important force due to the dam is the vertical force, which is also considered as the self weight of the dam. Second important force caused by the dam is hydrostatic pressure, which is due to the impounded water. This pressure will be different from the base to the top. At the base, this hydrostatic pressure will be maximum. As we move towards the crest of the dam, this pressure will go decreasing. Hydrostatic pressure may be calculated by W H2 divided by the 2 horizontal component when we are considering only the horizontal component, where H is the height of the depth of the water table or the height of the water table, and W is the specific weight of the water. The most important third type of pressure caused by the dam is upliftment pressure, which is caused by the water. It is impossible to find a site which is totally free from the voids, cracks and cavity in the rocks. Whenever there are small cracks, pores, joints and openings are there, a significant amount of water may seep down at the foundation of the dam, because the vertical component, that the self weight of the dam is compressive in nature, and if in such type of environment water may trap, so it may exert a upward pressure, because as we will go deeper, all these cracks, openings, icicles may die out, so it exert a upward pressure, which is very significant. There are so many examples in the world where the entire dam fails because of this upliftment pressure only. Sometime we may also consider the ice pressure. The ice pressure becomes significant when we are dealing with the permafrost region, because as we all know, when there is the freezing of the water, there may be an increase of the 11% of the water. So when we have a dam, when we have a reservoir, it may have a fixed capacity, and when this water may freeze, so this freezing water, by increasing its volume 11%, it may exert a extra pressure on the rock on the wall of the dam. So we have to also consider ice pressure when we are dealing with the permafrost region. There are so many examples in the world wide where the dam fails because of the improper geological investigation only. So there is a need for the very proper geological investigation. Step by step we will discuss about the various geological consideration for site selection of a dam. The first thing is the physiographic consideration. Physiographic consideration, we may prefer an area where the valley is V-shaped valley, or the aerial extent of the valley is less. This not only reduce the total construction of the cost, because we will have the less aerial extent of the dam, but this site may also help for in the power generation. Second important criteria is the occurrence of bedrock at the shallower depth. Whenever we have the rocks at the greater depth, or the river channel is filled with the sediment, this can increase the total cost of the area in many folds. Now one by one we will discuss about the suitability of different rock, that is the igneous, sedimentary and metamorphic rock, as the foundation of the dam. First, igneous rock. Most of the igneous rocks are massive if they are hyperbasal, and they may be very hard and compact when these are basicular. So all the massive or the fine grained rocks are suitable for the construction of the dam. In fact, the igneous rocks are considered as the most suitable rocks as a foundation of the dam. Volcanic rock, mainly the basalt, which is exposed in the all over the Maharashtra, this may consider as the best foundation rock for the reservoir, dams as well as for the reservoir. But the only condition is that it should not be affected by the lots of vesicles. This vesicular texture of the basalt is common throughout the Maharashtra. In many places, these vesicles are filled by the secondary mineral. Then the rock is termed as the amygdaloidal basalt. So when compact basalt we have, this may serve as a good foundation material. But when it is marked by the presence of vesicles or it is amygdaloidal basalt, this may create the problem after the construction of the dam. Metamorphic rock, gneiss, which have the strength similar to the granite or the basalt, this may consider as a good foundation rock unless it is not affected by the high degree of foliation and mica minerals. Schist, which have the very divisional planes or have the schistosity, these are not desirable at the dam site. Quartzite, which is formed by the metamorphism of the sandstone. Mainly when the cementing material is the silica, this may consider as a good foundation rock because these are neither porous nor permeable. Marble, that is the marble which is formed by the metamorphism of the limestone. Due to the dissolution character, it is not desirable at the dam site. Slate are undesirable as it is so soft, weak and have the slaty cleavage. The sedimentary rock, shale, which is a very fine grained sedimentary rock, it is not desirable at the dam site because of its slippery character. Well cemented siliceous sandstone may work, but it should not alternate with the shale. Normally in the nature we are getting the alternation of shale and sandstone. If only sandstone is exposed, which is massive in character, this may work good as a foundation of the rock. Laterite, limestone and conglomerate, because of their highly porous nature, these are not desirable at the dam site. Alternate, soft and hard rocks are not desirable at dam site. Now we will discuss about the influence of the weathering. Weathering is a disintegration of the rock masses due to the effect of the weather. So every rock is having their different attitude towards the weathering. It depends upon the chemical composition of that rock and the climatic condition of that area. It is very important to assess the degree of weathering at that particular area and sensitivity of the rocks before the construction of any large structure. As of now, we discuss about the implementation of the petrology, which we have studied in the petrology section for the site selection of the dam. Now we will discuss about the implementation of the structural geology or the associated geological structure for the site selection of the dam. Now I am taking the first case. In the area where rocks are horizontal, this geological situation is quite good for the construction of the dam because the load of the dam acts perpendicular to the bedding plane. This arrow indicates the self weight of the dam, which is downwards. From 90 degree to this arrow, there will be the pressure caused by the impounded water, and at this 45 degree to this, it will be resultant. So in this case, the resultant is at 45 degree. So this situation may consider as a good for the foundation of the dam. In the second case, this is the ground surface, downstream direction. Now rocks are dipping in the upstream direction. These are gently dipping in the upstream direction. Again we will consider self-weight of the dam, thrust caused by the impounded water, and this is the resultant because these two lines are at the 90-degree angle, so resultant will be at approximately at the 45 angle. Here the orientation of the rocks is just opposite to the resultant force. In this condition, this rocks, the orientation of rock will behave as a self-barrier. Here it may be the site for the water accumulation because this is the reservoir site. So in this case there are the very few chances of any failure, any landslide or any leakage. This situation is considered even the better than the horizontal strata. I am repeating, this situation is considered better than the horizontal strata. Third case, when rocks are dipping in the downstream direction, this is the general downstream direction, reservoir side, self-weight of the dam, thrust caused by the impounded water and resultant. Here we can see the resultant is parallel to the bedding plane. We are always considering bedding plane as the plane of weakness. In this situation, because the resultant force is parallel to the weak planes, there are the very much chances of the failure of this dam. There may be the chances the entire site may slip down. And in this situation, here we have shown a clay bed. Clay is very slippery in nature. These are weak planes. If water will enter in this clay layer, this will become very slippery. It will behave as a lubricating material, so entire mass may slip down. So this situation is worse. This is not desirable at dam site. When the rocks are vertical, it will not pose problem of the upliftment pressure on the dam or a leakage of the reservoir. It will not have the advantage in terms of competence of the rock. Now we will take the condition when rocks are folded. I am considering this line, this arrow as the ground surface. Now in a large area, rocks are folded. This is the crest of the dam, which is where the curvature is maximum. As you know, in a folded terrain, this is the point where the maximum crack will occur. If we are going to construct a dam in the crest area, then there may be the chances of the leakage of the water because of this crack. Now second situation I am considering here. This is similar like this. A reservoir is here and this is a syncline followed by anticline, anticline followed by syncline. If I will construct a dam in the synclinal area, the water may seep down from the reservoir side as well as water may seep down from the downstream side. So at the core of the syncline, a huge amount of water may accumulate and it may exert a extra upliftment pressure which can be problem for the dam and for the safety of the dam. Now these two situations are ruled out. Now we will consider about the third situation. In this situation, this is the reservoir side, self-weight of the dam, pressure caused by the impounded water and the resulting soil. Now in this situation we can see the orientation of the rocks adjust away from the resultant force of the dam. So in this entire folded area, this situation or this site may be the suitable site for the construction of the dam. So in a large area, when the rocks are folded, we may get some suitable points where we can construct a dam or which may be suitable for the reservoir. Faults are the geological structures which represent the relative movement of the blocks. This type of faults, whether they are active or not active, are not desirable at dam site, because this may be the site where in past some movement has occurred and we cannot deny such a movement in the future also. Whenever a fault is there, that means two huge blocks are moving past each other. Because of the movement of these blocks, a huge amount of rocks get crushed and sheared over here. So we may get a fault goes over here. Even this entire rocks are very sound and stable, but because of the movement of these two blocks, a significant area may become fragile or it may become powder. So whenever in this weak plane water may enter, this may behave as a lubricating material. So there are the chances that the downstream side may slip down. Irrespective of their orientation, their type, whether it is a normal fault, reverse fault or the strike slip fault, these are not desirable at dam site. But sometimes where we don't have the choice of any other site, we can overcome with this problem by the significant grouting, but this site may not be very reliable. The faults are the site where the movement has occurred in the past. Whenever the stresses are accumulating inside the rocks, this may be the points from where these stresses may come out. This or there may be the sudden release of the energy, that is the earthquake. So these faults may be the site of the earthquake. So in any case, we have to avoid the site where the faults are under the surface. We have the example of the collapse of the Kohinoor Dam, because this entire dam was constructed in the rock masses where the fault was present. So just after the filling of the dam, the entire site was experienced by the 6.5 magnitude earthquake, where there was a great loss of human and property occurred. Joints, these are the cracks or some oriented cracks in the rocks. Joint are the most common structural feature in the rock which are found each and everywhere irrespective of rock type, whether it is a igneous rock, sedimentary rock and metamorphic rock. This contributes the physical weakness of the rock and also the porosity and permeability. But the thing is that as we will go deeper inside the joints, the intensity as well as the space or the effectiveness of the joints may die out. So whenever we have rocks which are highly jointed, if we will go deeper inside the earth, then these joints may die out. It is important to remove the highly jointed part of the area where we are going to construct a dam.